Yep.
So Kevin has a talk about electronic line noise in our videos, and take it away, Kevin.
Okay, hopefully everyone can hear me. If you can't, let me know. And I've just shared, I've just gone to the slideshow, but it's going to take a second. It's not on my screen yet. Come on, there we go. All right, so you should be able to see my title page, line noise and occultation.
It's coming over well.
Sorry? Okay, great. Okay, so here's the issue, and this came up, I believe it was in the European meeting last year when Bob Anderson was giving a talk. And people had pointed out that there can be line noise in the data, and if you, let's see, let me move that. You can see that in the plot here, where there's these horizontal lines. Some places it's dimmer than others, some places it's a lot brighter, and it's important to notice that I have changed the contrast a bit. Sometimes this is not so pronounced. But nonetheless, if you have a star here that's either a target or reference star, you know, there are certain frames where, in fact, you've got an over enhancement here that you aren't taking into account with the background subtraction. So this is one type of interference that can show up, and it produces a non-uniformity in the background between the frames, between frames and between reference stars and frames. I'm going to show you one example of this. This was an actual event taken, observed this year in April. It was one of the last ones we've done. It's been cloudy ever since, which is part of the answer, Dave Harold, to why you have fewer events here from the United States. The weather's been absolutely lousy. But this event, there are two chords here. One was from Rick Bria, who's down the road from me in Connecticut, and then we are at Westport in Connecticut. We're both pretty close to the coast and 80 kilometers from New York City. So the background light can be pretty high. 14th magnitude star, magnitude drop was 0.7, less than your criteria, Roger. So you probably don't even care about this effect, but for those of us who are trying to push the envelope, this can be a big deal. Max duration on this one was 5.6 seconds. We use a Celestron 14 Edge HD combined with a QHY 174. This is our site. It's a fixed telescope here. This is an old Nike radar site. Nike was a program in the late 50s that was looking for bombers coming in from the Soviet Union dropping nuclear bombs, and this is where the radar was to try and early detect those bombers so that we could shoot missiles at them if they were ever to come. And the program ran for 3 years and then was obsolete because of ICBMs. But anyway, our telescope's up in this dome here. I have another picture of it in my next talk. So to get rid of this line noise, it's actually really easy to do. So these are basically on the same horizontal line here. So all you have to do is make a correction. You find the median of the signal for each horizontal line, and you find the departure of that median from the overall median of all of the medians, and you just subtract the difference. And if you do the subtraction wrong, the lines get worse, but if you do the subtraction right, then you get something like this. So this is the same, or this is the same frame where you have line noise. It's raw on the left, but then you take out the line noise and you get the image on the right, and you can see it's a little clearer on the right. What I found for this particular event, if for the source on region and for the background both, the standard deviation, which is your noise term, the standard deviation in the overall signal between frames was reduced by about 8.5%. And you can see that in this plot from IOTA. The blue line is the is the target, the green or the blue dots. The green dots is from a reference star that's of comparable magnitude. And the one on the left here is the uncorrected. And if I'll just point your attention to this area up here where you have a whole bunch of parameters at 100,000 count, and you go over here, and all of these come down to about 95,000 counts. There's another one here on the reference star. You can see down here where it looks pretty close to the the dimming that occurred in the reference star looks pretty close to where the target was. And if you bring it back, if you then make the correction, you can see it cleans things up just a little bit. There's a few more over here. This point over here goes away, and etc. So there's everything just comes in just a little bit. It's very simple correction. So when you do that and you run it through IOTA, this is what you get for the uncorrected on the left. If this is a familiar plot for those who run it, if this red line is to the left of the black line, well, then perhaps it's not so significant, even though the output was probability very near zero of this being a noise event in the uncorrected. But after you make the correction, in fact, you have the red line being significantly to the right of the distribution. This was for a, the other thing I should notice is the signal to noise is quoted went from 2.73 to 3.74. That seems too large for the effect that we were seeing, but nonetheless, it was a clear improvement. So the DR went from a 6.68 plus or minus 0.13 second event to a 6.61 plus or minus 0.09 second event. So, just generally at the edges, it affects things. I've seen this also in a even dimmer one where the mag drop was 0.2. I didn't have time to put that into the presentation, but as that mag drop gets dimmer, or as your star gets dimmer, the effect of this line noise becomes a little stronger. And so just a couple comments. With the event shown, if I did a light curve normalization, I could get, in fact, that this red line would go to the right. So maybe I'm being a little untrue here to the topic, but nonetheless, there's clearly an improvement in the significance of the event by taking out that line noise. The image that I had with the QHY, you can bin it up on a 2x2, and I did that on the fly. So that can enhance the visibility of the line noise, but it also improves the signal. So it's give some, take some. The other thing is that the line noise can increase if you increase the gain on that QHY, really on any detector. I've seen similar lines on the WATEC. I can show that at a different time if people are interested in that. But conclusions for this one is that line noise is quantifiable and it can be removed. For very high signal to noise events, that probably isn't going to affect your result, which I think is what most of you, I'll call you old timers, concentrate on. But for those of us trying to push down into the signal to noise a bit, this can make the difference between a detection and a non-detection. And I'll stop there on that one.
Can you approach your next topic with comparable efficiency?
Yes, there are about 3 more slides. 3 more in addition, so about 15 slides total. But yes,